article buddy. Sit and join me. Let's make learning science easy and fun. Come, let's get on the rocket ship. Together, let's explore the wonders of the world. Don't let your dreams be dreams mga kabangsa dahil basta pagbansa, katalino. Our objective for today is to describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. Mga kabangsa, handa ka na ba? Are you ready to join me in our Aragon adventure? If yes, please prepare your pencil, paper, and learning module. But oops, not yet. Let's play a game first. And this is Who Wants to Be a Sci Expert? Get the correct answer?
Yes!
That's great, Pagasa. Now, let's drive around. Did you know what's going on deep beneath your feet? Beneath this moving car. Get ready to dig deep because the secrets buried inside the planet will soon be revealed. To really understand Earth, you need to travel 3,977 miles beneath our feet. But the deepest humans have ever drilled was just over 7.6 miles, and even took 20 years. But still, scientists plunge Earth's inner structure by studying how earthquake waves travel through the planet. Here's an imaginary slice of our planet Earth. Think of the crust as the thin shell that covers the Earth. The crust is the one we live on. Lithosphere, from the Greek word lithos, which means rock, is the thick layer of solid rock, including the crust. Below the crust is the Earth's thickest layer, called mantle. Near its upper edges forms a layer of partially melted rock known as a asthenosphere. Differences in temperature in the asthenosphere allows convection to occur. Geologists believe that this weak, hot, and slippery part of the mantle is what Earth's tectonic plates ride ahead and slide across. But what is this tectonic plates? Tectonic plate theory states that the Earth's solid outer crust, the lithosphere, is broken into plates. These plates move and slide over the asthenosphere. Oceanic and continental plates come together, spread apart, and interact at boundaries all over the planet. All of these were made possible by the process called convection current. Convection current at the Earth's mantle. Convection happens when the temperature difference exists. Hot fluids rise and cold fluids sink. Then current or movement are created. Heat in the mantle mainly comes from the outer core. The temperature difference of the upper and lower boundaries of the mantle causes heat transfer. The less dense material near the core slowly moves upward. Relatively cooler material above slowly sinks towards the mantle. And this cycle continues. Now, let's go back to the plates. Do you remember the 7 major plates?
Yes!
Fantastic! We have the Antarctic plate, African plate, Eurasian plate, Indo-Australian plate, North American plate, South American plate, and Pacific plate. The arrows in the map shows the direction of each plate. Plates sometimes converge, diverge, or transform. Earth's surface is composed of large and small plates, such as the Philippine plate. Large or small, these plates play a big role to geologic activities such as earthquake, volcanoes, and mountain formation. Are you still with me, mga kabangsa?
Yes!
Excellent! Now let's proceed with our activity. Here is our first map. Lend me your eyes and keenly observe the location of the red triangles. What did you observe? The red triangles on the map shows the location of active volcanoes in the world. Pay attention in the areas where these active volcanoes are located. Based on the map, how are volcanoes distributed? Where can they be located? Volcanoes are not randomly distributed over the Earth's surface. Most are concentrated on the edges of continents, along the margins of tectonic plates, along island chains, or beneath the sea. 60% of all active volcanoes occur at the boundaries between tectonic plates. Most volcanoes can be found along a belt called the Ring of Fire that encircles the Pacific Ocean. Want more, mga kabangsa? Here is a second map. Take a glimpse on the map and tell me, what does it show? Marvelous! The second map shows the distribution of earthquake around the world. The dots represent the earthquake epicenters based on its magnitude. Now, based on the map, how are earthquake epicenters distributed? Where can they be located? Just like volcanoes, earthquakes are not randomly distributed around the Earth's surface. Earthquakes are located in distinct zones near the plate boundary where most crustal movements are felt. They are highly concentrated in a region called Pacific Ring of Fire. The Philippines is also located. As the plates move, their boundaries collide, spread apart, or slide past one another, resulting in geological processes such as earthquake. Finally, our third map. What does the map show? This map shows the distribution of mountain ranges around the world. Mountain ranges are not randomly distributed over Earth's surface. Mountain ranges are also located near plate boundaries. If we take a look at all the maps, the distribution of active volcanoes, earthquake epicenters, and mountain ranges, we can say that most of the active volcanoes, earthquake epicenters, and major mountain ranges are not randomly distributed because they all tend to occur along limited zones or belts. They are all located in areas near edges of continents at plate boundaries. The distribution of active volcanoes, earthquake epicenters, and mountain ranges are basis of our knowledgeable scientists in dividing the Earth's lithosphere into several smaller pieces called plates. Mga kabangsa, why is it important to identify the location of these geologic activities? Do you have any idea?
Yes!
Fantastic! It is is important to identify these areas so that necessary precautions could be done if ever you are living in the identified areas. How far did you enjoy our adventure today, mga kabasa? If you enjoyed today's episode, give me a big thumbs up. Great! Now, let's test yourself. You only have to answer 5 questions. I will read the question and carefully choose the letter of your best answer. You will be given 10 seconds to answer each question. What are you waiting for? Let's get started. Question number 1. Where is volcano most likely to form? A. Indian Ocean. B. Mid-Atlantic Ridge. C. Ring of Fire. Or D. Florida. Question number 2. What drives tectonic plate movement? A. Gravity. B. Convection currents. C. Coriolis effect. Or D. Earth's magnetic core. Question number 3. Theory that Earth's crust is divided into plates and the plates move around on the mantle. A. Seafloor spreading. B. Continental drift. C. Plate tectonics. Or D. Earthquake. Question number 4. Which of these most likely results from plate movement? A. Sandy beaches. B. Global winds. C. Mountain ranges. Or D. Ocean currents. For question number 5. Are volcanoes, earthquake epicenters, and mountain ranges randomly distributed? A. Yes. Or B. No. Did you get the correct answer?
Yes!
Great! Here's your Aracam ticket for your next Aracam adventure. Mga kabangsak, katalino ka talaga. Now, we'll learn to describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. Hoping to see you in our next episode. Maasalam!